Hello everyone, welcome to my channel. My name is Akash. Today we are going to discuss about the wave equation and its related questions and solution with proper concept. So don't waste any time, start the solution. This is the wave equations and this is the initial conditions. ux0 equal to f of x0 less x less than l, u2x comma 0 and equal to g of x 0 less equal to s less than n. Boundary condition u of 0 comma t equal to u of l comma t equal to 0. Okay, so this is the solution from D'Alembert principle. We get u of x comma t equal to half of x plus ct and half of x minus ct plus 1 by tc to c integration x minus c2 to x plus c2 g of x dx. Okay, this is the solution of finite rod since this is the boundary condition 0 to L. Okay, what is x plus ct and what is x minus ct? This is the domain of correspondence. So if we this is the x-axis, this is the t-axis, so x plus ct equal to k1, then this implies x by k1 plus t by k1 by c equal to 1 and x minus c2 equal to k2, then this implies x by k2 plus t of minus k2 by c equal to 1. This can be written as k1 equal comma 0 and this can be written as 0 comma k1 by c. Okay, and this can be written as k2 comma 0 and this can be written as 0 comma minus k2 by c. So this is equation is this and this can be written as this. Okay, this range will be called the domain of dependence. This is the, so if this is called q, this is called p and r, so pq are triangle, the coordinate of q is k2 comma 0 and coordinate of r is k1 comma 0. If the intersection of the line x plus ct equal to k1 and x minus c2 equal to k2 is x1 comma y1, then we can also say that x1 plus ct1 equal to k1. This implies x plus ct equal to x1 plus ct1 and similar x minus c2 equal to x1 minus ct1. This area is called domain of dependence. Here this is the x plus ct and x minus ct denotes the domain of dependence. Okay, now this is the question. The question said that get 2022. Let u of x comma 0 be the solution of the wave equation. This is the wave equation and with the initial condition u of x comma 0 and u2x comma 0 equal to 0 and the boundary condition u 0 comma 2 and u of pi comma t equal to 0, t greater equal to 0, then the value of u of pi comma pi by 2 comma pi is this. Since u of 0 comma t equal to 0 and u of pi t comma 0, this is called the homogeneous wave equation. If u of u 0 comma t and u pi comma t not equal to 0, then this is called the non-homogeneous wave equation. In the next class we discuss about the non-homogeneous wave equation. Okay, today we discuss homogeneous wave equation. So how to solve this type of question? We know the formula. Since this is the 0 x less than pi. This is the bounded value of x is bounded, so we use this formula. Okay, so start the solution. So from D'Alembert principle we get u of x comma t equal to 1 by t f of x plus ct plus f of x minus ct plus 1 by 2c x minus ct x plus ct of u2 of x comma 0 and dx. So this implies half of, here is c equal to 1, since this can be written as del 2y del x to 2 equal to del tu del dt. This is the form of wave equation. So c is this, c is 1. Okay. So we get again, this is the form of u of x comma t. So x equal to pi by 2 and t equal to pi. So half of f of 3 pi by 2 minus pi by 2 plus half, and u2 x comma 0 equal to 0, so half into 0. So here this is the f of x, this is the f of x, this equal to f of x. Now sin x, sin 2x and sin 3x. Now half of sin 3 by 2, sin 3 by 2, sin 3 by 0, sin pi 0, this sin 9 pi by 2, that means sin 9 pi by 2, that means sin of 9 into pi by 2 plus 0. So cos 0, this implies 1. So half of 1 minus 1, this equal to 0. So option B is the right answer. This is a theorem. The theorem says that ux comma t be any solution of the given wave equations, and a, b, c, d be the vertices of any parallelogram whose sides are characteristics curve, that is the lines parallel to x plus ct equal to 0 and x minus ct equal to 0. Then u of a plus u of c plus u of b plus u of d. That means you say this theorem says that x plus ct whose sides are parallel characteristic curve, this is the lines. So if we draw this and this, this and this is the a point, this is the b point, this is the c point, this is the d point. So the theorem, this is the parallel lines, this is the parallel to the curve. So we know that the parallel line of x plus ct equal to x plus ct equal to k1, and the parallel lines of x minus c2 equal to 0 is x minus ct equal to k2. This is the parallel line of x minus c2 k1. Okay, so this is the draw this theorem. This is the picture of this theorem. So from this theorem we can easily see that u of a plus u of c equal to u of b plus u of d. So now how to solve this theorem? We use x plus ct equal to 0, and parallel line of x minus ct equal to 0. Parallel line of x plus ct equal to 0 is x plus ct equal to k1 and x minus ct equal to k2. So we can draw this line parallel to x plus ct k1, and we also draw this line. This line is also parallel to x minus ct equal to k2. Okay, so now this is the point. So we can say that this is the point as u of pi by 2 comma 0, and this is the from this u of pi by 2 comma pi. Okay, this is the point of u of 0 comma t, and this is the point of u of pi comma t. This is the pi, x equal to pi. From this theorem we can say that u of pi by 2 comma 0 plus u of pi by 2 comma pi equal to u of 0 comma t plus u of pi t. So we know that u of 0 comma t equal to 0 and u of pi t comma 0. u of pi t comma pi equal to pi by 2 comma pi equal to u of pi by 2 comma 0. This is the minus, and this is the f of x. u of x comma 0 equal to f of x. Now put the value. So if we put the value, we can say that minus sine pi by 2 minus sine pi minus sine 3 pi by 2. This implies minus 1 minus 0 minus of minus 1. This implies minus 1 plus 1 equal to 0. So this is the answer.